So let's do a proof involving a rectangle so we can use the new properties on these proofs. Nothing's really new here, right? I'm trying to prove triangle ZMY is isosceles. How do we show it's isosceles? Show it's got what? Congruent sides. So we can do this, right? I can prove that's true somehow, or I can prove the angles are congruent. All right. For our purposes here today, we can do both, but let's just focus on getting MZ and MY congruent. Those won't be congruent unless, have we learned this all year? Those won't be congruent unless I prove what first? The triangle's congruent, right? Prove the triangle's congruent, I could say CP, CTC. All right, so there's our goal. Can you get me triangle WMZ congruent to triangle MXY? Can we do this? And the first thing is, for whatever reason, I have the wrong givens in there. But you guys have the right one, so I'm going to start by asking somebody here to use the second given. M is the midpoint of WX, and tell me what's true. All right? I never want you to do this, but for time's sake, I am. Okay, so by M being the midpoint of WX, what do you know is true up here? True. 2, Zoe. There you go. WM congruent to MX. There's our first pair of sides. Definition of a midpoint. And now I can put an S next to that. Good. All right, so now you're going to have to use your rectangle properties for me. Okay, what do we know about a rectangle that I can use in this proof anyway? There's a lot of rectangle properties. I don't need them all. I just need a few. Name something else that's true, because that is a rectangle up there, because that's a rectangle. Ones, Will, what do you know is true? Okay, so all angles are right angles, but for me, I don't need to say all of them, right? I just need to say W and X. So angle W and angle X are right angles. And now usually we've always said what? Perpendicular lines form right angles, definition of perpendicular, maybe even definition of altitude. All right, but I don't have any of those here. What do I have? I have a rectangle. So just like we did with the parallelogram proofs, we're going to write it the same way. Just start out with the word rectangle. So rectangle, and you can abbreviate it, RECT, implies, now tell me the property, all right angles. And just like we've done in the past, now tell me those right angles are congruent. So angle W congruent to angle X, all right angles congruent. And there's an A for you. And I need one more pair. And it's going to come again from being a rectangle. All right, what else can I say is true up here, because this is a rectangle? Here we go. What else is true? Josh?
WZ and XY.
Yeah, I keep saying it. I can't say it enough. It's also a parallelogram. Remember, all the parallelogram properties apply. Good, Josh. WZ is congruent to XY. Now, how do I start this up? You can say, hey, take a look. I could put rectangle implies. Is it wrong if I put parallelogram implies? No, because a rectangle is a parallelogram. So whether you write rectangle or parallelogram here, it doesn't matter. It would matter in the last one, though. You got to write rectangle. That's only for a rectangle. But here, rectangle or parallelogram implies opposite sides congruent. And that gives me my other pair of sides that I needed. We're good now to say the triangles are congruent. Triangle WMZ, order matters, remember? And if I go WMZ, we got to go what? WMZ XMY. And what's the method then? Why are these triangles congruent by Matt?
Side angle side.
Side angle side, good deal. Why do you need the triangles congruent? To say the sides were equal. MZ, MY. MZ congruent to MY. Let it roll off the tongue like usual. CP, CTC. And now we have an isosceles triangle. Hopefully we didn't go over that too fast. ZMY, triangle ZMY is isosceles. And for our proof, how do we know it's isosceles? Don't tell me the in a triangle business. That doesn't tell me why it's isosceles. How do we know this is isosceles now? It's got two congruent sides imply isosceles triangle. All righty. We all good? And now I'd like to welcome you to the new type of proof. I know you're excited. A proof now where you're going to graph a figure and prove to me it's a certain type of quadrilateral. Right? Just to give you a name of these proofs, anytime we're asked to graph and prove something, these are referred to as a coordinate proof. Why coordinate? Because you're putting it on the coordinate grid. So this is a coordinate proof. When I'm asked to graph and prove. Graph and prove. So first, I'll let you go ahead and graph quadrilateral PQS. Take a minute to do that. Because there are a lot of new things that are going to come at you right now, and I got to slow the pace down a little bit. Ready? Show it's a rectangle now. Okay? Show me it's a rectangle. This is a lot different than any proof we've done. A lot different. There will not be any statements, reasons here. There'll actually be numbers involved. All right? No statements and reasons, numbers involved, and some algebra involved. First, how can I do it before I show you all the methods behind it? I gave you 3 different ways we could prove this is a rectangle. Because what you guys want to do is, I need to know this is definitely a rectangle and not one of the other quadrilaterals in the family. All right? So by you guys just saying, oh, there's a right angle, makes it a rectangle. No, could still be a trapezoid. Trapezoids have right angles sometimes. I need you to somehow show me this is definitely a rectangle and none of those other quadrilaterals. And there are 3 ways to do it. All right, 3 ways. I could show this is a parallelogram. Show me it's a parallelogram with a right angle. That makes it into a rectangle. You could show me it's a parallelogram with congruent diagonals. Or the way we're going to do it, I don't even want to talk about a parallelogram. Let's get to the point right away. If you can show me all 4 of these angles are right angles, it's automatically a rectangle and none of the others. So that's the way I'm going to do with you. Show me Q is a right angle, R, S, and P are right angles. How am I going to do that now? All right, how am I going to do that? Because now I have points, I have numbers. We're going to have to rely on 3 formulas that we've talked about all year long. If angle Q is actually a right angle, what am I going to know about line PQ and line QR? They have to be what to each other? Perpendicular to each other. Okay, let's think back. Probably, I think it was unit 3. If 2 lines are perpendicular, Ziv, slopes are negative reciprocals. Let's say that word again. Slopes are negative reciprocals. So the first formula we're going to need when we do a coordinate proof is the slope formula. Anybody remember that one? Anybody remember the slope formula? Come on, give me a break. Josh. Okay, rise over run. You actually stole my fire, but I love using rise over run when it's graphed because you could just count. If some of you are uncomfortable and you'd rather plug in actual numbers, you can do change in y up top over change in x. So that's what we're going to need for this proof. But you're going to do other coordinate proofs where maybe you don't need to know about right angles. Let me put this scenario to you. If you were to prove it's a parallelogram, you could do opposite sides are congruent. How do you show opposite sides congruent? What am I going to need to bust out? Everybody's favorite. Go ahead. distance formula. So there's the second formula you may need. And I said there was 3 you may need. These are the main 2. There is a third if you get a little nuts. What's the other formula you usually associate with all these 2? Midpoint formula. Yep. You're probably thinking, why would I ever need a midpoint? We'll get to it. You've used the midpoint formula already this unit. I don't know if you remember when, but parallelogram diagonals. y1 plus y2 divided by 2. Let's review our plan before I show you how to write a coordinate proof. We are going to show the slopes of all these are negative reciprocals of each other. Because if they're negative reciprocals, they're perpendicular. And what do perpendicular lines do? Forms right angles, I'll have a rectangle. So that's my goal. All right. Show the slopes are negative reciprocals, to say the lines are perpendicular, to say I have right angles, and then I have a rectangle. Now, how do I show all this? Organized fashion. Organized. We are not doing statements, reasons. Instead, we're just going to keep all our work organized. So you are still going to have step 1. You are still going to have step 1, but it's not 2 columns anymore. Step 1, pick a formula you're going to use. What did we agree on? We have to use what formula here to show they're perpendicular? What formula do we need? Slopes. So here we go. Ready? Let's do the slope of QR first. So the m for slope of QR equals however you're going to find it. Are you a plug in the coordinate person and do change in y over change in x? Or are you a rise over run person? You decide. All right, me, I'm comfortable with doing rise over run because I can just count it on the graph. So QR, I go up 2 over 3. And if you plugged in your coordinates, you'd get 2 over 3. But anybody want to look at QR, please? There's something I'm missing. Look at QR. It's going downhill, right? So this should be a negative slope. All right, we got to find the slopes of everything because I need to know their negative reciprocals. So what do you want next? RS? So the slope of RS. Plug in R and S, or plug in the coordinates, or do rise over run. Whatever floats your boat. So up 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4. 6 over 4. Positive or negative? RS? Positive. I'm going to warn you, though. I'd probably make sure everything's simplified. Because look at these 2 right now. It doesn't look like they have any relationship, but they actually do. You just got to simplify 6 over 4 to 3/2. Ooh, now I'm seeing a little something, right? Negative 2/3, positive. Oh, okay. That's what I wanted. Quick note, if you're ever uncomfortable reducing, you just go to your calculator, type in 6/4, enter, and it'll give you the reduced answer along with the decimal. Okay, so use your calculator if you ever want to reduce. All right, let's keep going. We still have what? PS? Slope of PS? Oh, look at that. That's convenient. It should be up 2 over 3. And they should come out to be these values. It's going to be a rectangle. It will be. I'm telling you it is. It's not a yes or no question. It's going to be a rectangle. You just have to show me why. So if you get negative 2/4, you better go back and check your work. Either you counted wrong or you graphed a point wrong. All right? It should all work out to be a rectangle at the end. And then finally, we got what? PQ? And PQ, what do I go? Up 6 over 4 again? So 3/2. So step 1, the formulas you used. Step 2, What did you just learn by using those formulas in step 1? What did we just learn about the segments here? Well, we noticed QR had negative 2/3 and RS had 3/2. What did we just learn there? What did we just learn about QR and RS that I could put between those? If one came out to be negative 2/3 and the other came out to be 3/2. Aren't these negative reciprocals? So those two are perpendicular. So we learned QR is perpendicular to RS. We learned more though. We also learned that QR is also perpendicular to negative 2/3. What else came out to be 3/2? PQ. Okay, let's go. There's two more here that we learned. We also learned that, let's see, what? RS is perpendicular to PS. And then the final thing we learned was, what's the next two lines? PS and QP. Yeah. Right? I don't have that yet. PS perpendicular to QP. And then tell me why. Because this is like kind of like, little reasons column, but not there. How do you know that? Why did you write they're perpendicular? What did you see up in step 1? What told you they're perpendicular? Steve? Because slopes are negative reciprocals. All right, now start thinking about how would you do a statement's reasons. What would be right after the perpendicular statement? Telling me what? The right angles, right? They're all right angles. So angle Q, angle R, angle S, and angle P are right angles. Because don't change what you've learned. Don't change it because it's something in a new style. Because, Ian? Yeah, because perpendicular lines form right angles. And I understand where you want to go in the next step. You want to tell me they're congruent. You can if you want, but I have the right angles. Now it's a rectangle. All right, I don't need to know that they're congruent to make it a rectangle. I just need to know you got 4 right angles. So if you want to tell me they're congruent in step 4, you can. It's not needed because all I need is right angles. So my step 4 is going to be, what is this, PQRS? PQRS is a rectangle. And then just tell me why you know it's a rectangle. Because it has 4 right angles. Whoa, 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 whoa. I know you guys I like the intensity. Questions here. This is the only time I'm going to ask you to do a coordinate proof. I'm never going to ask you to do a coordinate proof to prove triangles congruent. It's always going to be, here's a figure, prove it's this type. Prove it's a rectangle. We're about to do a rhombus in a couple minutes. Prove it's a square, a trapezoid when we get that far. All right? Go ahead, Charlie.
Could you use distance formula to prove that the diagonals are congruent?
You can, but you have to prove it's a parallelogram first. Okay? Because if you just prove the diagonals are congruent, it could be a rectangle, could be an isosceles trapezoid too, because that's one of the properties of those. All right? So you have to make sure it is a rectangle and none of the other quadrilaterals. Okay? So if you want to do that, yes, but prove it's a parallelogram. Questions? And that was my other point before we moved on was, this is one of 3 different ways I could have proved it a rectangle. Remember, I just went over with Charlie. You could have proved it a parallelogram with congruent diagonals. You could have proved it a parallelogram with only 1 right angle. All right? All my piece of advice is, when you go into next week's test on Thursday, have a method down in your mind you're going to go with. If he asks me to prove a rectangle, I'm doing it this way. Don't make the decision game day. Okay, don't make the decision as you're taking the test. Have it already in your mind how you're going to do it. Questions on here? You're ready to go to a rhombus now. 1 statement's reasons, and then 1 coordinate proof if we have time here, I hope. All right, ABCD is AECB. Sorry, AECB is a rhombus, and I have to prove those sides. All right. So in the given FAB, make sure that's that full angle is congruent to DCB, this full angle here. I sound like a broken record. FE and DE aren't going to be congruent unless the triangles that contain them are, right? It's always that way. It's always going to be CPCTC. All right, so can you get me triangle FAE congruent to triangle EDC? Because if you can, those sides will be equal. You can go rhombus on me, or you can go non-rhombus and something else that you see in that diagram. You tell me where you want to go here. Rhombus properties or something else that you see that has nothing to do with the rhombus. Let's roll. Woo, going deep. That's me. I'm not giving this away. Here we go, Doyle. Let's roll. Any side? Oh, sorry.
Angle EAB is congruent to angle ECB.
Oh, you are going hardcore right away. You're finding the tough pair first. I love it, Doyle. Love it. Here's what he's saying. The opposite angles in this rhombus are congruent. He is correct. He is correct. The opposite angles. Why would he need that? He's not even in the triangle, Doyle's. He's not even in the darn triangle. Why is he doing that? EAB congruent to ECB. Just like I talked in the previous statement's reasons, you could write rhombus here or parallelogram because it's a property of both. Rhombus implies opposite angles congruent. I'm not going to put an A next to that, right? Because it's not in the triangles. Not going to put an A. Where are we going from here? Anybody want to take over for Doyle? Or hey, you know what? Just go nuts. Go off the grid and do your own thing. Whatever. You see where it's going, but you know what? I'm going to be that kid and say something else, which is fine. Go ahead. Your show. Ian?
FAE and DAE are supplementary. And
Whoa, wait a second. Wait. Hold on, boss. Say this again.
oh wait, not supplementary. Wait. Congruent parts. Like if those two are congruent, like the two we just proved are congruent.
Yeah.
And then they have, but the whole angle is congruent.
Yeah.
Those other parts are congruent.
Okay. That is true.
Yeah.
What's that called? You're overthinking this. Subtraction, yeah.
All right.
Yeah. There's nothing supplementary here. I hate to break it to you. There's no straight lines here. There's no linear pairs here. You good on this is just subtraction? You're making me worried.
No.
Okay, you've been hanging out with Matt too long. All right, here we go. Angle. Now I'm getting rattled. FAB minus angle EAB equals angle DCB minus angle DCB ECB. Those angles are equal, and those, the ones next to them are. Yeah, we know. A little thing we call subtraction. And then substitution will say the angles in the triangles are equal, right? Angle FAE congruent to angle DCE. Now I'll put an A next to that bad boy. Now, hey, this should be smooth sailing from here. I thought the hard pair was taking care of it right there. That was the hard pair to see the subtraction. The others are properties of a rhombus and something that's not a property of a rhombus. So where do you want to go from here now? 1, 3, where am I going here? Castilla, where are you going? Yep, using that non-rhombus property here. Angle FEA is congruent to angle DEC. Little thing we like to call vertical angles are congruent. And there's another A for me. I hate to break it to you, the third one's not going to be an A, huh? Got to be a side somewhere. So start searching. If you can't see it, start searching. It's got to be a side. We're still not using angle in this class. Never will. All right, so where is that side that we're looking for? Where's that? Ah, nope, not going to give it away. Doyle, back to you. Where's that side? And here's a hint. We have yet to talk about this thing was a rhombus for a reason. What do you know about a rhombus? I'm going to look back at your properties from yesterday. You can see it right off the bat. The main property of a rhombus that none of the others have. Relax. It's not your show anymore. All right. You got it, Doyle. We have faith in you. Can't be worse than what Ian just said. What do you notice about a rhombus? I'll point to it for you. Just get to the page. You won't forget that ever again. So now tell me what's true here.
Side AE is congruent to EC.
Yeah, there we go. AE, you'll never forget that property. AE congruent to EC. Now, here I have to put rhombus. I can't start it with parallelogram. It's not a property of a parallelogram, only a rhombus and something else, but we haven't gotten to it yet. Rhombus implies all sides congruent. And then hopefully you guys are finishing this up. You can on your own. What's the method going to be here before I finish mine up here? Is that side in between or not, right? Because it could be angle side or angle side angle. Figure out if the side's in between or not. And what's the method of proving the triangle's congruent? There we go. Haley. ASA, thank you. That side is in between. And then we'll finish it off with the CPCTC. Oh boy. Only 4 minutes. Still be what?
Why does it matter if you say like angle side angle or angle side? Because it's wouldn't they both technically be true?
Here, based on what we did here, Ian, here's what I was told. These two sides are equal. These two angles are equal. This one up here, right? Nope, sorry, this one.
Why it's angle side angle?
Yep.
Well, if you said angle side, wouldn't that technically be true?
But that means the side's not in between them. Okay? It doesn't mean you have two angles on the side. All right, it means that the side's in between or it's not. That's the difference between the two. Okay? Because if that was the case, we'd only have 4 methods. You could just put AAS in any order you want. But that's not the case. All right? Everyone good? Okay, let's see how much we can get through here of the last one, which is prove this is a rhombus. Probably not going to be able to do this in 3 minutes, but I'll talk as much as I can about it. Make sure I order some darts tonight.
When's the spelling bee?
Friday, next Friday. Given we don't have a snow day. Because if we have a snow day, I got to push the test back to Friday. Okay, like a rectangle, we proved all 4 angles were right angles. Doyle, what was the fact you just learned about a rhombus?
All sides are congruent.
All sides are congruent. So that's how I could prove this is a rhombus. But instead of using slope formula like the rectangle, what formula am I going to need here to show all 4 sides congruent? Distance. So the way I would start this is, all right, find the distance of AD. Find the distance of DC, CB, and yeah, you got to do all 4, unfortunately, if you do this method. And the distance of AB. Okay, so I do the distance formula. Again, guys, they have to be the same. If one's wrong and one's, you got three that are equal and one that's not, you did something wrong. Okay, so it should all come out to be the same. And then in step 2, you tell me all 4 sides are congruent. And then you end it with it's a rhombus because all 4 sides are congruent. Okay, so that's pretty much in a nutshell how these coordinate proofs are going to go. All right, you're going to try, I think, 2 out tonight. 2 statements and reasons, and then 2 coordinate. Before we leave, though, we got time. Before we leave, your coordinate proof may not match mine on Classroom. Bring it in tomorrow, and I'll still check it. All right, because there's multiple ways of doing these coordinate proofs. So don't freak out, and certainly just don't copy it. All right, try it out yourself, and we'll talk tomorrow.
We have to finish.